Oxy acids में there are some parts which is factual, some part which is conceptual. उसको तो देखेंगे. Then you have hydrolysis. This is important. There are many reactions for hydrolysis. Then you have allotropes, which is factual. Silicates and silicones, again, this is going to be factual. Drying agent and bleaching agent, this is also factual points. And then the reactions and the compounds of group 13 till 18. This is also completely factual. You just star wale topics, all of these are what? These are conceptual topics. So there will be two things. I will be explaining the conceptual topics. Okay. I will explain the conceptual topics and I will give you notes for the factual one. Allotropes, silicates and silicones, drying agent, reactions and compounds. Okay, so for that I will give you notes. Then today I will do the explanation and I will also teach you some of these parts. And then after that, tomorrow we'll be having questions. Okay, so we'll be doing PYQs tomorrow. आज we are not going to do any questions because जब P block elements के आप सवाल देखेंगे, then you will see that multi-conceptual होते हैं, है ना? There will be some question in which किसी एक topic से नहीं आ रहा. So I cannot cover half topic today, half topic tomorrow, and then deal with the questions. So tomorrow I will be dealing completely with the questions only. Okay. Just a second. Moving on. Please write these points. Group 13 is known as the boron family, and it has the outer electronic configuration as NS2 and NP1. What does this mean? It means that it has, what is the number of valence electron? Valence electron will be equal to 3. This N is valence shell. This N is also valence shell. And it has 2 electrons in the S subshell and 1 in the P subshell. And as we go and we move from group 13 to 18, the number of valence electron is going to increase. So in the P subshell, P1, P2 से लेके P6 तक. ठीक है? So please write this down. Now, important point regarding the nitrogen and chalcogen is what? Nitrogen is called nitrogen because there are poisons which are being formed from these elements, and chalcogens because most of these compounds are ore forming, sulfides and oxide majorly, but the whole group is known as chalcogens. Then उसके बाद जो हमारे पास फ्लोरीन फैमिली उसको तो हैलोजन ही बोलते हैं, ठीक है? Then we have the noble gases. All of you done? Yes, all of you tell me. All of you wrote this? Yes or no? Can someone tell me what happened? Itna shanti rahega?
Yes, sir, done.
Okay. Now, moving on. Back bonding. Please, पहले सुन लीजिएगा आराम से, ठीक है? Then you can write this whole thing down. What is back bonding? Back bonding is, first of all, it is a coordinate type bond. ठीक है? Coordinate bond. When can coordinate bond form? Coordinate bond can only be formed if you have a lone pair electron and then the another atom. There will be two atoms in a bond. One atom should contain lone pair and the other atom should have what? A vacant orbital. ये क्या होना चाहिए इसके पास? It should be having a vacant orbital. Then only a coordinate bond can form, and that are the conditions for the formation of back bonding also. Must have lone pair electron. Another species must have a vacant orbital, huh? And then the size of atom should be small. If it is large, then the coordinate bond will not be formed from the back bonding. Okay. Now, when does this happen? Back bonding आपको मिलेगा दो cases में. Back bonding में generally मिलेगा, you will have a p-pi bond. And what is p-pi bond? P-pi bond happens when you have the lone pair electron which are giving the electrons on p orbital. अगर ये p orbital में electrons दे रहे हैं, then that means it is p-pi. There is another one which is known as p-pi d-pi. In p-pi, what happens? The lone pair is given to the d orbitals. It's given to the d orbitals. Okay. As you can see here, in the first example, we have B and X. X are what? Fluorine, chlorine, bromine, and iodine. That is halogens. Now, boron, if I look at BF3, so boron will be having 3 bonds. Now, fluorine, all the fluorines contains 3 lone pair electrons. And this boron, it will be having a vacant orbital. Why? Because it is only having 1, 2, 3 bonds. 3 bonds means 6 electrons. 6 electrons means it is not what? It is not completing the octet. 8 electrons complete nahi hai yahan pe. That means there will be a vacant p orbital here. And all the fluorines can give the lone pair electron. And we also say that it exhibits resonance in back bonding. That means all of these bonds, they are having partial double bond character. They have partial double bond character. Now, if I compare fluorine, chlorine, bromine, and iodine, which is able to give which is able to donate and which is able to form the back bonding most effectively, then in that case, we have to look at the size. Since boron and fluorine, both of them, they belong to the same period, the second period element, the lone pair electrons will be in the p orbital. And the boron will be also having the 2p orbital, which is vacant. Fluorine ke jo lone pair electron, they are in the 2p orbital, and boron's vacant orbital is also in 2p. So 2p overlapping will be very effective. Then followed by 2p 3p, then 2p 4p, then 2p 5p. That is why the extent of back bonding is greatest at BF3, BCl3, BBr3, and Bi3. Now that is why when I compare the electron deficiency. Now when I compare the electron deficiency, all of these are not electron deficient, but when I talk ki sabse zyada electron kiske paas hoga, then BF3, since the extent of back bonding is best here, this is the least electron deficient. BF3 kya ho jayega? Least electron deficient. Okay. Now, if this is least electron deficient, then also this will be also what? This will be the least acidic, right? It will be least acidic halide. Why? Because if the electron density is high, ye yaad rakhega, tab ye kya ho jata hai? Base ho jata hai. And when the electron density is low, then that is acid. So sabse kam electron density kahan pe? BF3 mein. That is why it is what? It is the least basic. Sorry, it is the least. It is having the least acidic strength. The acidic strength kahan pe? Bi3 mein. Why? Because it is most electron deficient. It is most electron deficient. Okay. Now, there are a few more examples. For example, if you have the example of tricylyl amine and then you have trimethylamine. Trimethylamine mein kya hota hai? You have nitrogen attached with CH3. Tricylyl mein kya hoga? Silyl mein you will have silicon hydride. We have SiH3. Here we have CH3. Here we have SiH3. What is the difference here? The only difference that you can see here is we have nitrogen and carbon bond. Here we have nitrogen and silicon bond. Now, in this case, when you have nitrogen and silicon bond, nitrogen can donate electrons to silicon, which is having vacant d orbitals. And when there is a vacant d orbital, then it will be forming a trigonal planar structure rather than the pyramidal structure of trimethylamine. And also, since this is having a pyramidal structure, there is no back bonding. This lone pair electron, it is not delocalized. It is present there with nitrogen only. But the nitrogen's lone pair electron in tricylylamine, it is donated towards the silicon atoms that are surrounded. And that is what happens. The Lewis base strength also decreases. ठीक है. Extent of back bonding जहां पे भी increase करेगा. If the extent of back bonding increases, then the basic strength क्या हो जाएगा? The basic strength will be decreasing. As you can see in the case of BF3 also, here we have the most extent of back bonding and the Lewis acidic strength is what? Basic strength. Sorry, wait a second. दो cases में इसको divide कर सकते हैं आप. When you have, in this case, if you see, the lone pair is going towards the central atom, तो क्या होगा? Acidic strength decrease करेगा. And when the lone pair electron is going out of the central atom, तो क्या होगा? Basic strength decrease करेगा, है ना? And also it is going to differ the bond angle when I take the case of CH3 whole ether का case अगर हम ले लें, और एक क्या ले लें case when you have silyl ether, silicon का अगर ether है हमारे पास, then in that case what is happening? The bond angle is going to change. Here we are going to have, in this case, the bond angle is what it is, very less if I compare to this bond angle. ठीक है, चलिए, please write this down. मेन पॉइंट्स क्या आपको समझना है? दिस एसिडिक स्ट्रेंथ एंड बेसिक स्ट्रेंथ. ठीक है, चलिए प्लीज राइट दिस डाउन अबाउट बैक बॉन्डिंग. Let me know once you're done writing. Let me know once you're done, guys. Yes, done everyone. Yes or no, please tell me.
Yes, sir.
Okay. Now let us look at dimerization. Okay. Dimerization is easy. There are two types of dimers that you can have. There are 3 centers and 2 electron. This is also known as banana bonding. And then you have 3 centered 4 electron. And this is basically when you have coordinate bond. I will give you an example using, let us take B2H6. Okay. So when you have B2H6, these bonds are like this. We have one boron here, and then you have one boron here. Both of the borons are what? BH3. Get this a bit. Then you can have BH3 and BH3. You have 2 hydrogens here like this. And these are how many hydrogens? 1, 2, 3, 4, 5 hydrogens. Okay. So this will also be somewhere like this. Hydrogen, hydrogen. Okay. So let us suppose we have BH3 like this. This is one BH3, and this is another BH3. Now there are 2 electrons in each of the bonds here, right? Here we have 2 electrons. Here also we have 2 electrons. But what happens? These 2 electrons are then shared to this boron atom because boron is what it is, electron deficient. So this hydrogen makes a bond like this. But in this bond also there are only, so here we have how many centers? 1, 2, 3 centers. And how many electrons are making the bond? There are 2 electrons. These are the 2 electrons. And ये पूरे क्या होते हैं इस तरह से? They revolve around this whole 3 atoms. And then here also you have 1, 2, 3. और ये इस तरह से भी revolve करते हैं यहाँ पे. So as you can see, it looks like banana, and इसी को क्या बोलते हैं? These are known also as banana bonding. Next, we have the case of 3-centered and 4 electron. जो आपके पास कब होता है? When you have BeCl2. And now, when you have BeCl2, दो BeCl2 होंगे. So you will have something like this. You have beryllium. Yeah, beryllium. Beryllium. Chlorine, chlorine, chlorine. Now, chlorine, they have lone pair electrons. This chlorine also will have lone pair electrons. This chlorine also has lone pair electrons, and this chlorine also has lone pair electron. So we have two chlorine, BeCl2, and then we have VeCl2. So this chlorine will donate a bond to beryllium like this, and this chlorine is going to donate a bond to beryllium like this. Now, in this case, what we are having a dative bond, coordinate bond. Okay. This is the case of BeCl2, where you have what? 3 centers, and how many electrons? There are 4 electrons. How there are 4 electrons? Because what are the centers here? This beryllium is one center. This barium is one center, this chlorine is another center, and this beryllium is another center. So we have 3 centered, and how many electrons? These are the 2 electrons, and then the dative bond, this is also having 2 electrons. So 3 centered 4 electrons and 3 centered 2 electrons. One is known as banana bonding, and the other is also having, it is an example of coordinate bond. यहाँ पे आपके पास 2 cases होते हैं. You can have dimer इस case में, but if you have BeCl2 and then you have N, that means there are N number of BeCl2, then this is the case of when you have polymers. Okay, this is a polymer. Okay, so please write this down. 2 types of dimerization that we have. Done, guys. Achha, okay, fine, sir. Can you please message me after the class? Please message me after the class, okay?
Okay, sir.
Moving on, we have oxyacids. Now, what are oxyacids? Oxyacid, they will have a general formula. You will have hydrogen, you will have metal, and then you have oxygen. So these are what? Oxyacids. Those acids which also contain oxygen atoms. Okay. Now, please write this down. इसके बाद हम लोग कुछ example करेंगे, then you will understand. ठीक है. So in general, you will always have the ic acid. ठीक है. आपको कहीं से भी मतलब when your starting point should be ic acids. What are ic acid? जैसे for example हो गया आपके पास sulfuric acid, H2SO4. Phosphoric acid हो गया आपके पास, right? Then you have boric acid. All of these are what example of ic acids. ठीक है. Please write this down. Ic acid में क्या होता है बताइए? Ic acid has, for example, if you look here, then what is the oxidation state on sulfur? Sulfur का oxidation state कितना है? +6, right? So ic acid, they have the highest oxidation state possible. उसी तरह से अगर phosphoric acid में क्या होगा? You will have H3PO4. यहाँ पे phosphorus पे क्या oxidation state है? 4 2 is 8 minus 3, that is equal to +5. ठीक. उसी तरह से अगर you look at nitric acid, HNO3. Okay, here also nitrogen is having +5. ठीक है, 3 2 6 -1 is equal to +5. In the case of pyro, what you need to do, you need to have 2 moles of oxy acid और उसमें से आप पानी निकाल दीजिए. ठीक है, पायरो से याद रखिएगा क्या करना है आपको. ठीक है, 2 और even if you have 2, ठीक है, 2 और 2 में क्या आ रहा है, O आ रहा है. And then what you have to remove, you have to remove P. क्या निकालना है आपको, पानी निकालना. So you have to have 2 ic acid, and from the 2 moles of ic acid you remove 1 mole of water, you will get pyro. ठीक है, फॉर एग्जाम्पल अगर आपके पास सल्फ्यूरिक एसिड है तो क्या मिलेगा, पायरो सल्फ्यूरिक एसिड. ठीक है, नेक्स्ट यू हैव मेटा. मेटा केस कब होगा, फ्रॉम 1 मोल ऑफ ऑक्सी एसिड, यानी कि 1 मोल ऑफ सल्फ्यूरिक एसिड, 1 मोल ऑफ फॉस्फोरिक एसिड, किसी भी एक एसिड से आप क्या निकाल दीजिए, एक पानी का मॉलिक्यूल निकाल दीजिए. व्हाट यू आर गोइंग टू गेट, यू आर गोइंग टू गेट दी मेटा फॉस्फोरिक एसिड, मेटा सल्फ्यूरिक एसिड. Then you have per oxy acid. Per oxy acid में क्या होगा, you will have 1 bond which is oxy bond. ठीक है, एक आपके पास ऑक्सीजन ऑक्सीजन वाला बॉन्ड होगा. Then there is another case when you have hypo acids. हाइपो में 2 केस बनते हैं, एक होता है हाइपोअस एसिड एंड हाइपोइक एसिड. फॉर एग्जांपल you will have hyposulfurous acid, hyposulfuric acid, hypophosphorus acid and then phosphoric acid. आपको क्या करना रहेगा, हाइपो केस में अगर आपके पास अस एसिड है उसमें से आप एक ऑक्सीजन निकाल दीजिए तो यू विल गेट हाइपोअस एसिड. एक एसिड में से ऑक्सीजन निकालिएगा तो यू विल गेट हाइपोइक एसिड. ठीक है, नेक्स्ट दीज आर द एग्जांपल्स हियर यू कैन सी. जैसे फॉस्फोरस एसिड का एग्जांपल है H3PO3, है ना. So H3PO3 is, this is phosphorus acid. Phosphorus acid में से एक ऑक्सीजन निकाल दीजिए H3PO2. What you are going to get? You are going to get the phosphorus acid. We'll look at examples. अभी इसको लिख लीजिए पहले. Done everyone? Yes or no? Please tell me.
Yes, sir.
यहाँ पे before I move that side, let me give you some example. For example, if you have pyrosulfuric acid, first of all, you need to know what is sulfuric acid. Sulfuric acid is H2SO4. What you need to do to get pyro में you have to have 2 molecules of H2SO4 and then minus H2. ठीक है, तो 2 molecule कैसे लिख सकते हैं इसको, so you'll have 2 molecules of H2SO4, यानी कि what you are having H4S2 and how many O, O8. ठीक है, अब यहाँ से आप क्या निकाल दीजिए, 2 water molecules if you are going to remove, oh sorry, 1 water molecule, then 2 हाइड्रोजन और 1 ऑक्सीजन निकालना. वो 2 हाइड्रोजन, that means you are going to have H2S2 और 1 ऑक्सीजन O7. H2S2O7, this is the what, this is going to be your pyrosulfuric acid. Structure कैसे बनेगा इसका, please see. Whenever you have the pyro form, then in that case you will have SOS bond. ठीक है, SOS bond. एक चीज आप याद रखिएगा, तीन केसेस ले लीजिए आप. When O is oxygen, number of oxygen is what, it is less than 7, then all the bonds that you are going to make will be SS bonds. ठीक है, if you have oxygen that is equal to 7, then it is going to be what, SOS. ठीक है, and when you have oxygen that is equal to 8, then in that case you will have SOOS bond. ठीक है, इस तरह से बॉन्ड होगा आपके पास SOOS. now in this case we have oxygen that is equal to 7. आप कैसे स्ट्रक्चर बनाइएगा इसका, सल्फर ऑक्सीजन bonded to sulfur. In each and every acid you will add double bond O, at least 1 double bond O should be there. कोई भी आप एसिड बनाइए उसमें एक डबल बॉन्ड O होना है. ऑक्सी एसिड में देयर शुड बी एटलीस्ट 1 डबल बॉन्ड. ठीक है, या 1 डबल बॉन्ड O and there should be 1 OH. ठीक है, So for each sulfur, I will give one OH and I will give another OH here like this. Okay, I will give another OH here. Now, what is remaining here? How many oxygens are remaining now? 1, 2, 3, 4, 5 oxygen is done. There are 2 oxygens remaining. So यहाँ पे एक double bond O और आ गया and यहाँ पे भी एक double bond O और आ गया. So what you need to do first of all. Now I'm not talking about sulfuric acid या फिर sulfur के case का, not acids of sulfur. In general speaking, 1 double bond O should be there. Z double bond O, that means non-metal double bond O, and 1 Z bonded to OH should be there. ठीक है ना, यहां से स्टार्ट कीजिएगा. अब उसके बाद आपको कोई भी स्ट्रक्चर बनाना बहुत आसान हो जाएगा. फॉर एग्जाम्पल, आप बनाइए H3PO3. ठीक है, so first of all I will have phosphorus double bond O and then I will have OH. Once I am done, once you're done with this, now what you are going to see, is there any OH that you can add? Can we have any more OH? Yes or no? Tell me. Can we have any more OH? How many oxygens are remaining? Remaining oxygen is equal to how much? Tell me. And remaining hydrogen is equal to how much? Please answer, guys. Answer नहीं कीजिएगा, नहीं समझ में आएगा, ठीक है ना?
One oxygen.
One oxygen is remaining.
And 2 hydrogen.
2 hydrogens are remaining. ठीक है, यानी कि एक OH हम डाल सकते हैं, right? There is 1 oxygen and 1 hydrogen लेके I can add 1 OH like this. Correct? Yes or no? Please tell me, guys. सही है?
Yes, sir.
अब क्या बचा? Only 1 hydrogen, right? So this is the structure of H3PO3. This is the structure of what? H3PO3. Yeah. देखिए H3PO3 ना आपको कभी कभी इस तरह से ही मिल सकता है. They will ask you what is the structure of POH whole thrice. But आप ऐसे प्लीज मत बना दीजिएगा. ठीक है. Now, सबसे पहले क्या करना है आपको? फर्स्ट ऑफ ऑल यू हैव टू मेक 1 Z double bond O and 1 ZOH. Now make maximum number of ZOH. अगर आप बना सकते हैं, if there is remaining, if you have oxygen and hydrogen both remaining, तो जितना भी आपको हो सकता है उतना OH bond बना लीजिए आप. If not, then तीसरा क्या करना है? अगर आपके पास कुछ नहीं बचा, then what you have to do? Make ZH bond with remaining hydrogen and Z double bond O with remaining oxygens. ठीक है, इसको प्लीज लिख लीजिए and please try to answer when you are drawing this. मतलब जब भी आपको हम बोले ना किसी स्ट्रक्चर के बारे में, then please थोड़ा कोशिश कीजिएगा बनाने की. ठीक है. Done everyone? Yes or no? Please tell me. Please let me know once you're done. Done?
1 minute, sir.
1 minute, okay.
Done, sir.
Done. ठीक है. Let us draw the structure of sulfuric acid. H2SO4. ठीक है. And H2SO4, what we are going to do? First of all, S double bond O, and then I will have SOH. Now tell me, can I make any more OHs? Then there will be.
Yes, sir.
Okay. How many more OH? Tell me.
One more.
One more OH, right? What is the remaining? Hydrogen or oxygen?
Oxygen.
So double bond. ठीक है. All of you understood this? Yes or no? Please tell me.
Yes, sir.
Okay. Then you have one case जिसको आप थोड़ा सा ध्यान से कीजिएगा. That is nitric acid, HNO3. So in HNO3 also you will be having nitrogen. There will be a double bond oxygen और एक bond आप किसके साथ बना लीजिएगा? OH के साथ. Now we have one oxygen that is remaining. ठीक है? One oxygen that is remaining. So many people what they do, they will draw like this double bond को. ठीक है? क्या करेंगे? Double bond को बना देंगे. ठीक है? But this is not the right structure of nitric acid. Nitric acid में क्या होता है? There is a dative bond that is between oxygen and nitrogen यहाँ पे अब. ठीक है? Because कितने bond बना ले रहा है nitrogen? Nitrogen is making 5 bond. 5 bond is not 5 bond का मतलब क्या हो गया? इसके पास 10 electrons है. Nitrogen cannot have 10 electrons. सिर्फ 8 ही electrons हो सकते हैं. तो that is why this bond here, it is a dative bond rather than a covalent bond. ठीक है? This is a dative bond. Nitrogen lone pair, it is giving oxygen. Lone pairs to oxygen. ठीक है? So याद रखिएगा nitric acid. But if you have anything beyond the second period, यानी third, fourth, fifth या sixth period का कोई element है आपके पास, then in that case these are the rules. ठीक है? ये जो rules हैं, these are all right for these compounds. ठीक है? Let me give you one more. For example, you have H2S2O8. You have what? H2, then you have S2, and then you have what? You have O8. Now, what should be the structure? See, you have what? 8 oxygen, right? 2 sulfurs and 8 oxygen. Then you will be having SO, O, S bond. ठीक है, सबसे पहले आपको ये कैसे पता चला? Because you have 8 oxygen. So, similarly, if you have this structure also, na, H2SO5, this one. ठीक है? In this case also you will be having H2SO5. तो यहाँ पे भी अगर आप इसको डबल कीजिएगा, 2 सल्फर के केस में 10 ऑक्सीजन आ जाता. And in that case also you will be having what? You will be having S double bond O, S bond. ठीक है? But I will leave that later. अभी इसको देख लेते हैं. So when you have S double bond O, S, अब आपके पास क्या करना है? Double bond O एक होना चाहिए. There should be a double bond O here also. There should be a OH here also. There should be a OH here also. Now, what is remaining? Can we have any more OHs? No, because hydrogen सारे के सारे खत्म हो गए. How many oxygen are remaining? We have 1, 2, 3, 4, 3 and 3, 6 oxygen. So 2 are remaining. So double bond O and S double bond O. Please write this down. How will we make pyrophosphorus acid? How will we make pyrophosphorus acid? Pyrophosphorus acid के लिए क्या करना पड़ेगा? You will have to first of all take the phosphorus acid. What is phosphorus acid? Phosphorus acid is going to be, you will have one phosphorus atom and then how many hydrogens and how many oxygen? You will be having H3PO3, right? This is phosphorus. इसका दो ले लीजिए आप. You will have H6P2O6. Remove one water molecule, so you will be having H4P2O5. ठीक है, H4P2O5. Now, whenever you have pyro, in that case, you will be having non-metal oxygen and then non-metal bond. So you'll have POP bond. Phosphorus, oxygen, and phosphorus. Now double bond oxygen will be there, double bond oxygen will be here also. Then you will have OH and OH. Now see what is remaining. What is remaining now? Oxygens are done. 3 and 2, 5. We have 2 hydrogens remaining. So one phosphorus will get 1 hydrogen, the other phosphorus will get another hydrogen. Can everyone else please tell me? All of you wrote this? Okay. Let us look at the oxy acids of halogen. In the case of hypohalous acid, you will have only OH bonded to halogen. Then you have hypo आप हटा दीजिए, ठीक है? Hypo, once you are removing the hypo, that means you are what doing? You are doing adding a double bond O, ठीक है? Halous acid में halous से hypohalous कैसे जा रहा है? You are removing this oxygen atom, ठीक है? Then again there is halic acid. Halic acid में क्या हो रहा है? Halic acid में you are adding one more oxygen atom. Per halic acid में you are adding one more double bond O, ठीक है? So this is a very easy trend to remember. Hypohalous में you will have 0 double bond O. Here you will have 1 double bond O. Here you will have 2 double bonds O. And here you will have 3. Okay? So please write this down. Also important point is to note here is that the oxidation state is increasing. +1 से +3 because you have added oxygen. Oxygen का oxidation state होता है -2. So halogen का हो जाएगा +3. Right? So these are the examples. Please write this down. अच्छा, this we have already done. चलिए ठीक है, कोई बात नहीं. इसको लिख लीजिए oxy acids. Okay, right, next. Oxy acid that contain SS linkages. Okay. So what is SS linkage? This SS linkage is known as thio. And that is why these are known as polythionous acid, or you will have polythionic acid. For example, you can have, what example can I take here? You can have elements such as thiosulfuric acid हो सकता है आपके पास, or you can have polydisulfuric acid. Okay, so all of these examples are what for whenever you are having SS linkages. Now, the only difference that you have to remember is in when you have us acid, उसमें you'll have oxidation state of sulfur as +3. एक acid में आपके पास oxidation state होगा +5 का. You'll have an oxidation state of +5. ठीक है, please write this down. One more question that can come here is with this statement. How many SS linkages can be there? So if you have S2, तो क्या होगा? अगर 2 सल्फर है तो एक SS linkage होगा, right? So how many number of SS linkages could be there? So you will be having number of SS linkages equal to number of sulfur atom minus 1. जैसे 2 था, 2 minus 1 is equal to 1. तो 1 sulfur linkage. अगर S3 हुआ आपके पास, in that case, how many linkages will be there? There will be 3 sulfur linkages. Sorry, 2 sulfur linkages. 3 minus 1. Right, next point, that is the acidic nature of oxy
1 minute,
acids.
sir. Done, sir.
Now, simple thing about acidic nature of oxy acid is what it is. The strength of oxy acid, it is going to depend on the oxidation number of the active element. Active element हो गया जैसे for example sulfuric acid में sulfur हो गया active element है ना, जो non-metal है, ठीक है. So simply what you have to do, it is directly proportional to oxidation number, है ना. For example, if you have sulfurous acid and sulfuric acid, तो us के case में you have +3 और एक के case में you have +5, ठीक है ना. All of sorry +4 and +6, right? So when you have sulfurous acid, तो उसमें +4 होगा, sulfuric acid में +6. That is why sulfuric acid is going to be more acidic. Also in the cases of halogen acid, now in this case also, perhalic acid is going to be most acidic. Then you have halic, then you have halous, and then you have hypohalous because the oxidation state is increasing from hypohalous to perhalic. Okay. The only exception is in the case of oxy acid for phosphorus. In this, the acidic nature is inversely proportional to the oxidation number. S3PO2 सबसे ज़्यादा acidic, then you have S3PO3, then you have S3PO4. So please write this down. Now, these are the cases when you have the same central atom. If the central atom is different, but the oxidation state is same, then you have to use this rule. Acidic nature of oxy acid is directly proportional to the electronegativity of active element. This is what electronegativity. If you have different elements, All of you done? Yes or no? Please tell me. Please let me know once you're done. हाँ जी, done guys. चले आगे. Is everyone done?
Yes, sir.
See here. Hydrolysis. ठीक है. Hydrolysis, that is the breakdown with water. Using water. Hydro means water. Lysis means breakdown. So when you break down a molecule through water and then form new product, this is known as hydrolysis. The important thing is that hydrolysis is a nucleophilic substitution reaction, and specifically speaking, it is SN2 reaction. क्या होता है ये? SN2 reaction. Nucleophilic substitution. Nucleophilic substitution में आप एक चीज ध्यान रखिएगा हमेशा. There is a nucleophile that is incoming, and in this case, the incoming nucleophile is generally OH negative. ठीक है? OH negative attach होता. Actually, the nucleophile that is going to attack is water. लेकिन जो आपके पास नया group attach होता है, that is going to be, it is generally OH negative. ठीक है? OH वहां पे जाके अटैच होता है. Then next thing है आपके पास leaving group. ठीक है? आपको क्या देखना पड़ेगा? लीविंग ग्रुप कौन सा है? सो नाउ लीविंग ग्रुप इज गोइंग टू चेंज विद रिस्पेक्ट टू व्हाट डिफरेंट मॉलिक्यूल्स. अलग अलग मॉलिक्यूल के लिए अलग अलग लीविंग ग्रुप होगा. ठीक है? नाउ इफ यू लुक एट द फर्स्ट एग्जांपल हियर, BeCl2 है. ठीक है? वी हैव BeCl2, वाटर ऐड किया आपने तो क्लोरीन तो हट के क्या आ गया? OH2 आ गया. कैन यू सी दैट? यस और नो? प्लीज टेल मी. कैन ऑल ऑफ यू सी दैट? सिंपल मैकेनिज्म हियर. यस और नो? अगर आपके
Yes,
पास
sir.
इस तरह से कुछ होता RCl और आप उसमें वाटर ऐड करते तो क्या मिलता है आपको? ROH मिलता है, अल्कोहल, राइट? It is not alcohol, but same, the mechanism is same here. Chlorine is getting removed और OH atom वहां पे आके उसको क्या कर रहा है? Replace कर रहा है. All of the examples that you can see here, from beryllium, you see boron, aluminium, silicon. ठीक है? Then you have SF6. Now this SF6, it does not get hydrolyzed. ठीक है? उसका हम example बताएंगे. Then similarly, CCl4 is also not getting hydrolyzed, and then carbon also not getting hydrolyzed. That means there is some condition that has to be fulfilled. There is some condition that has to be fulfilled whenever we are having hydrolysis. So hydrolysis का वो condition क्या है? What is the condition that has to be fulfilled? The first condition is that, and the only condition is that, one atom should have vacant orbital. क्या है? One atom should have vacant orbital. ठीक है? और जिसमें वेकेंट ऑर्बिटल होगा उसी में OH आके अटैच होगा. इज दैट अंडरस्टूड? यस और नो? प्लीज टेल मी. बात समझ में आई सबको? यस और नो?
Yes, sir.
ठीक है? नाउ if you have two atoms which are having vacant orbitals, ठीक है? There are two atoms which are having vacant orbital. So the one which is what it is, if it is electron deficient, तो वो वहां पे जाके अटैच. If it is electron deficient, या फिर central atom generally जो होता है, that is going to be that वहां पे OH अटैच होगा. For example, अगर आप BeCl2 की बात करें, बेरिलियम क्लोराइड की बात करें, then beryllium is also electron deficient. Beryllium is electron deficient, and chlorine is what? Chlorine has vacant orbital. Chlorine के पास vacant orbital कैसे हो सकता है सर? Chlorine के पास vacant orbital हो सकता है because it is what? Third period element. और third period में होने की वजह से 3D is vacant. ठीक है? So beryllium also has vacant. Chlorine also has vacant orbital, but chlorine is not electron deficient. ठीक है? तो nucleophile कहाँ अटैक करेगा? Electron deficient side पे, that is beryllium. Now, if I look at SF6, then in SF6, what is the case? SF6 में sulfur, it is what? It is having a vacant orbital. It is not electron deficient, लेकिन उसके पास क्या है? It is having a vacant orbital. But because fluorine इतना ज़्यादा वहाँ पे लगा हुआ है, there is no case कहीं से भी OH negative आके attach नहीं कर सकता. ठीक है, and I said that it is what it is SN2. It is what it is SN2, and since it is SN2 it will be dependent on the steric hindrance. If crowding is more तो वहाँ पे SN2 हो नहीं सकता, ठीक है. So if you have crowding then वहाँ पे SN2 नहीं होगा. In the case of CCl4, carbon here it is not having what, it is not having any vacant orbital. Chlorine के पास यहाँ पे vacant orbital होता है, but because it is chlorine that is not going to get attached, ठीक है. So please write this down.
Sir, should we write all the reactions?
अभी रुक जाइए आप. You will take a screenshot of this, ठीक है, बाद में लिखिएगा. अब यहाँ पे देखिए, next case BF3 हो गया है ना. In BF3 also what we are saying, you are saying that water is getting reduced. अब next case आ रहा है आपके पास NF3. Now in the case of NF3 what is happening here, नाइट्रोजन के पास तो extent, sorry, if I talk about nitrogen it is not electron deficient. नाइट्रोजन के पास नाइट्रोजन है, 3 फ्लोरीन है, and there is a lone pair. तो 2 4 4 6 और 8 ऑक्टेट इज कंप्लीट. फ्लोरीन के पास भी इट डज नॉट हैव वेकेंट ऑर्बिटल, ना ही इलेक्ट्रॉन डेफिशिएंट है, ठीक है. दैट इज व्हाई हाइड्रोलिसिस इज नॉट टेकिंग प्लेस. दैट इज व्हाई हाइड्रोलिसिस इज नॉट टेकिंग प्लेस. देन यू हैव द केस ऑफ NCl3. यहाँ पे आपका सवाल बनना चाहिए सर NCl3 में what is happening, nitrogen is acting as a leaving group और OH किसके साथ अटैच हो रहा है, क्लोरीन के साथ अटैच हो रहा है. Why it is attaching with chlorine? It is attaching with chlorine only because nitrogen के पास तो vacant orbital नहीं है, ना ही electron deficient है. Chlorine here is the one which is having vacant orbital, जो कि 3D orbitals है. 3D orbitals are vacant, that is why what is happening, that is why वहाँ पे आसानी से OH can attack and it can give the electrons and form HOCl, ठीक है. ये क्या बना रहा है, क्लोरस हाइलस एसिड बना रहा है, राइट ना, हाइपोहाइलस एसिड बना रहा है. देन इन द केस ऑफ PCl3 अब यहाँ पे चेंज आ चुका है. हियर phosphorus also has what, phosphorus has 3D orbitals which are vacant, that is why OH is attaching on phosphorus. और बाकी सारे केसेस में भी आप देख सकते हैं कि वही हो रहा है यहाँ पे, ठीक है. So please see at all of these cases. Then you have these cases जो आपके पास आता है when you have bismuth and you have what, you have PCl5 and then you have antimony. In these cases because of partial hydrolysis what happens, you are going to get SbOCl and BiOCl and POCl3, ठीक है, because of what, because of partial hydrolysis, ठीक है. Please write this down. इसका स्क्रीनशॉट ले लीजिए और ना इसको एक एक रिएक्शन को आप समझने की कोशिश कीजिएगा. किसके बेसिस पे, इसके बेसिस पे. वन एटम शुड हैव वेकेंट ऑर्बिटल, ठीक है. अटैक पानी का होगा कहाँ पे उसके हिसाब से, ठीक है. टेक अ स्क्रीनशॉट ऑफ दिस, देन वी आर गोइंग टू लुक एट द डिफरेंट क्वेश्चंस. और भी दूसरे रिएक्शंस हैं उसको देखेंगे. एंड दिस इज इंपॉर्टेंट, एक्सटेंट ऑफ हाइड्रोलिसिस इज डायरेक्टली प्रोपोर्शनल टू कोवेलेंट कैरेक्टर. कोवेलेंट कैरेक्टर आप लोग को पता होना चाहिए कि वहां से हम लोग कैसे निकालते हैं पजान रूल से. ठीक है, आई होप यू हैव टेकन स्क्रीनशॉट. नो, hydrolysis of higher covalent compound. Now in these cases also what you can see again, जहाँ पे वेकेंट ऑर्बिटल है वहीं पे जाके ऑक्सीजन अटैक करेगा. You have beryllium. Beryllium तो आपका ग्रुप 2 एलिमेंट है, राइट. तो वहाँ पे beryllium is going to be having a positive charge. Mg पे पॉजिटिव चार्ज होगा, कैल्शियम पॉजिटिव चार्ज होगा, एल्यूमिनियम पे पॉजिटिव चार्ज होगा, Mg पे पॉजिटिव चार्ज होगा, यहाँ पे एल्यूमिनियम पे पॉजिटिव चार्ज होगा, कैल्शियम पे होगा, यहाँ पे लिथियम पे होगा, यहाँ पे भी कैल्शियम पे होगा. तो wherever you have a positive charge वहीं पे आके OH is going to attach. Simple SN2 का आपको फंडा याद रखना. You have to remember what about SN2. Now, hydrolysis of interhalogen compound. In interhalogen compound, you have different types of interhalogen compound. You have HCl होता है मान लीजिए, then you have HI3, then you can have H or rather BF5, and you can have what, ClF7. So these different type of interhalogen compounds are there, and in each of the cases you are going to have what, HX type का एक आपके पास structure आएगा, ठीक है. HX type का structure आएगा, and then in the next what the byproduct will be HOA. अब ऑक्सीजन बस बढ़ाते जाइएगा, HaO2, HaO3, HaO4, ठीक है. यानी कि एक तो हाइड्रोहालिक एसिड मिलेगा, हाइड्रोक्लोरिक एसिड, हाइड्रोब्रोमिक एसिड, हाइड्रोफ्लोरिक एसिड, and the other one is going to be what, it is going to be either hypohalous acid, halous acid, halic acid or perhalic acid, ठीक है. Depending on what, depending on the starting one. If you have X3 तो क्या मिलेगा आपको, you are going to have halous acid. X5 है तो halic acid होगा, and then X7 है तो perhalic acid होगा, ठीक है. लास्ट में आपको ये 3 रिएक्शंस याद करने पड़ेंगे। किसका? नोबल गैसेस का। वाई नोबल गैसेस का याद करना पड़ेगा? बिकॉज नोबल गैसेस में ना ही इलेक्ट्रॉन डिफिशिएंट है यहाँ पे कोई, एंड नाइदर एनीवन इज हैविंग अ वेकेंट टाइप ऑफ ऑर्बिटल्स यहाँ पे। ठीक है, सो यू हैव टू रिमेंबर द रिएक्शंस ऑफ xenon. Xenon also, because it is very large, it shows different types of hydrolysis, not similar to the previous hydrolysis. Okay, so please take a screenshot for this also. Now, some of you may say, sir, ये कैसे पता चलेगा कि whether I should have 1 OH attached, 2 OH attached, 3 OH attached, या फिर कितने OH attached करना, वो कैसे पता चलेगा? You will know how many OH you have to attach looking at the oxidation state of the central atom. ठीक है, फॉर एग्जाम्पल अगर आप Mg की बात करें, Mg will have +2, तो उसमें 2 OH लगेगा। कैल्शियम का भी होता है +2, 2 OH लगेगा। एल्यूमिनियम का जनरल ऑक्सीडेशन स्टेट इज +3, तो 3 OH लगेगा। ठीक है, I hope you have taken screenshot. Now write the next part, that is inert pair effect. What is inert pair effect? Please see. And this is only applicable for the p block elements. P block elements में एक खास बात ये है, it has NS2 and NP can be 1 to 6. ठीक है, NP can be 1 to 6. But as we go down the group, NS और NP के बीच में you can have NS2, N-2F, N-1D and NP 1 to 6. ठीक है, F और D substance भी बीच में आ जाते हैं। Now, as more and more F and D electrons come between S and P, तो उस वजह से क्या होता है? Here we have the nucleus, and since S electrons are very near to the nucleus, they are attracted very easily. And these F and D subshell, they are not able to shield the S electron effectively of the valence shell, and that is why these S electrons, they feel a high level of attraction from the nucleus. If these S electrons are feeling a high level of attraction from the nucleus, these S electrons will be reluctant to form bond. It will not want to leave the atom. And if it is not wanting to leave the atom, that means they cannot take part in the bond formation. तो वही इसी को क्या बोलते हैं? इनर्ट पेयर इफेक्ट. That means the reluctance of an S electron to take part in bond formation. Now, what is the consequence of this? इसका consequence ये होता है, for example, if I take group 13. Now, group 13 में आपके पास 2 oxidation state हो सकते हैं. It can be either +1 because of NP1, and it can be +3 because of NS2 NP1. ठीक है, +3 कैसे होगा? तीनों इलेक्ट्रॉन दे दीजिएगा तो आप +3 हो जाएगा, एक इलेक्ट्रॉन दीजिएगा तो क्या होगा? +1 होगा. Now, as we go down the group, these NS2 electrons are not taking part in bond formation, and that is why the lower oxidation state is stable down the group. Stability of lower oxidation state increases down the group. तो वही अगर हम बात करें, for example, let us take thallium. ठीक है, तो thallium का +1 जो होगा, this will be more stable than thallium +3. Why? Because of inert pair effect. Is this understood? Yes or no? Please tell me, guys. Inert pair effect समझ में आया आपको?
Sir, can you explain it again?
It is first of all reluctance of an S electron to take part in bond formation. हमने क्या बताया इसमें? और हम ग्रुप 13 एलिमेंट्स है मान लीजिए, या फिर ग्रुप 14 ले लीजिए, ग्रुप 15 ले लीजिए, 15 लेके देखते हैं. 15 में आपके पास होगा NS2 NP. How many electrons in the p orbital? Tell me. How many electrons in the p orbital?
4.
4. ये तो याद नहीं है आप लोग को, कैसे चलेगा? ऐसे कैसे काम चलेगा? हाँ, NP will be anyone else? ग्रुप 15 के लिए व्हाट विल बी द कॉन्फ़िगरेशन NS2 NP
3 सर।
हाँ ये ऐड कर देना इस तरह से कि 5 बन जाए, ठीक है NP3। नाउ इफ द एलिमेंट इज एबल टू गिव ऑल द इलेक्ट्रॉन्स तो उसके पास मैक्सिमम ऑक्सीडेशन स्टेट क्या आ सकता है +5 का, ठीक है दोनों को दे दे। बट if the S subshell is not taking part and only the P subshell is taking part in the bond formation, then in that case it will be +3. ये बात समझ में आई आपको? There are two oxidation states which are possible.
Yes sir.
ठीक है। Now because the NS electron are not taking part in bond formation below, जैसे जैसे आप नीचे जाएंगे F और D वाले सबशेल्स आते जाएंगे, जैसे जैसे F और D वाले सबशेल्स आते जाएंगे, then in that case NS वाला इलेक्ट्रॉन क्या करेगा? It will be feeling a high level of attraction from the positive charge of the nucleus. Nucleus से वो it is feeling a high level of positive charge, a high level of attraction. That is why they are not taking part in bond formation. लेकिन कब होगा? When you have F and D orbitals. F and D orbitals कब आएंगे? In the top part of the group या फिर down part of the group. Obviously down part of the group. जैसे जैसे electronic number increase करेगा, atomic number increase करेगा, उसी तरह से electron increase करेंगे, and that is why you will be having more F and D orbitals. ठीक है? Now that is why we are saying if I compare SN2 positive and SN4 positive, तो यहाँ पे कौन ज्यादा स्टेबल होगा? In this case SN2 positive will be stable because down the group. Similarly bismuth is down the group, तो वहाँ पे कौन ज्यादा स्टेबल होगा? +3 will be more stable. But if I talk about let us suppose phosphorus, तो phosphorus के केस में क्या लिख सकते हैं हम? phosphorus के केस में हम लिखेंगे that phosphorus +5 is more stable than phosphorus +3. Why? Because it is not down the group, वो ऊपर ही है. It is not down the group, बिल्कुल low part में नहीं है, वो ऊपर ही है. Please write this down. ठीक है? So we have done the conceptual part today. जो भी एक्सप्लेनेशन वाला पार्ट था, बैक बॉन्डिंग कर लिया हमने, डाइमराइजेशन कर लिया हमने, इनर्ट पर इफेक्ट कर लिया हमने, ऑक्सी एसिड्स वी हैव आल्सो सीन, हाइड्रोलिसिस वी हैव आल्सो सीन. ठीक है? नाउ व्हाट यू आर गोइंग टू डू, हाइड्रोलिसिस के जितने भी एग्जांपल्स आप उसको स्टडी करने की कोशिश कीजिएगा. ठीक, रिएक्शन कहाँ पे हो रहा है? द ओनली थिंग दैट यू हैव टू लुक इज व्हाट इज द वेकेंट ऑर्बिटल या फिर जहाँ पे इलेक्ट्रॉन डेफिशिएंसी हो. ठीक है? फॉर द रेस्ट ऑफ दीज थिंग्स आई विल गिव यू नोट्स, वो आपको मिल जाएगा. एंड नेक्स्ट थिंग, टुमारो यू विल हैव अ क्लास एट मोस्ट प्रोबेबली एट 8:30 PM IST. ठीक है? 8:30 PM IST में कल आपका एक क्लास होने वाला है. दैट इज विल बी द नेक्स्ट पार्ट, जहाँ पे हम लोग सवाल लेंगे एंड वी आर गोइंग टू टेक क्वेश्चंस फ्रॉम देयर.